Hi everyone, welcome back to the course. Today we are diving into one of the most powerful and honestly one of the most misunderstood concept in JavaScript closure. Now you have been following along. You already know about the function, scope, and how variable works, right? Closures tie all of that together in a really elegant way. And once you understand the closures, you will unlock a whole new level of JavaScript mastery. So let's get started. The first question is, what is closure, right? In a simple term, closure is when a function remembers the variables from the place where it was created, even after the place is gone. Let me say that again because it's important. A closure allows the function to access variables from its outer scope, even after the outer function has finished the executing. Okay, so let me show you the example. Okay, look at what's happening here. The outer function that create a variable called outer variable. Instead, that we define the inner function which log that outer variable, right? Now, here is the magic. We return this inner function and store it in a my closure. You notice when we call this outer function, it finished executing and normally, right? You did think outer variable would be gone, right? But when we call this my closure, the output will be this. Actually, it also accesses the outer variable, and that's closure. The inner function close over the variable in its outer scope. Okay, and that's why this closure is little bit complicated, but even though if you are trying day by day, you could understand what is happening here. Now you might be wondering, why does JavaScript work this way? It all comes back to lexical scope. Remember, JavaScript use the lexical scope, which means functions are executed using the scope chain that was in effect when they were defined, not when they are called. So, when the inner function is created, it forms a closure with its surrounding the environment, and that includes the outer variable. Okay, so JavaScript keep that variable alive as long as the function needs it. Okay, and I hope you notice something here. Did you see what is it? You notice something? This calls the arrow function. When in variable you are using like this parenthesis, then equal, greater than, then the bracket braces, curly braces, it calls the arrow function. Okay. Okay. So now, okay. So now let's look at more practical example. Create a private counter. Okay. Suppose this is really cool. Okay. Remember, the counter variable is a private, right? Actually, this is private. You can't access it directly from outside. It's not possible. You can only interact with it through the method we return here, right? And each of these method has access this count through closure, right? So if we create another counter, it get its own independent count, like this counter true, and then you are calling this function, and when you are counter 2 dot increment, you get this increment again, right? Return, increment, decrement, and get count, and you easily access this function or anything insert from return. Okay, actually each closure maintain its own separate environment, right? Now the question comes up that closure in loops, the classic problem. Actually, these types of code example we have been seen upcoming tutorial or any types of real world project. You can see that you are used to it when you are practice more. Okay, just try to understand that what is the meaning of this closure actually. Okay, anyway, so closure in loop. Now actually, let's talk about one of the most common pitfalls with the closure. It's called the closures in loops. Take this code example first. What do you think? This will print it. You might be expecting 1, 2, 3 with delays, right? But before we are go to the, or we test it out in our terminal. So try to understand this set timeout is a function. Okay, it accepts first parameter will be a handler. Most of the time we are using the array function, actually calling the function, and second parameter is the number. If when you are hover over it, it's the timeout, and third is the argument. Most of the use case we are using the only these two methods, two parameter only, because this handler we need to control our handling what we actually want to handle, and this second parameter is the time set when it will be printed. Okay, so as I say, maybe you might expect 1, 2, 3 with the delays are printed, but it actually print 4, 4, 4, triple 4 actually. It's actually printed with triple 4. So okay, go to your terminal and test it out. Test out it first, then okay, go again. Go to your terminal first. Okay, before moving, give me a second. I'm just comment it. Otherwise, it's confusing you. What is happening? Okay. Note closer JS. You notice something? It's not immediately printed. It's printed little bit delay. After little bit delay. Okay. But why? Because var has a function scope, not block scope. Okay. This var. Var is a functional scope, not block scope, right? We know that. Most of the use case we are using the let, but here we are using the var. Okay. But by the time that the callback run, the loop has finished. I is 4. Okay. All three callback are closing over the same variable I, and that's why it's returned 4 3 times, except we accept the 1, 2, 3 incremented way. Okay. So now the solution number 1 using let, and we already know that how to use this, right? We already know, and you get this output like that. And another option is actually this is a really perfect. And why does this work? Because let has a block scope. We know that, right? Each iteration of the loop create a new building for I, right? So each callback closure over its own copy of I, not same copy. I mean the same number again and again. Okay, as like the bar do. Okay, this was the one solution using let. And another is IIFE. I mean the old school. I mean the old method. Before let exist, developer user immediately invoke function expression for IIFE. What it means? Here we create a new function for each iteration and immediately invoke it. Notice this is function, arrow function, and then passing the I as an argument. Okay. Actually, this create a new scope with the current I for each iteration. Each callback then closes over its own current I. Okay. And you will see this pattern is older JavaScript code, but nowadays we just use the let keyword. I mean the let variable. And this was is complicated, right? You see, this is the dependency. We are calling the function, this is the arrow function. Function is closed here. Then call this dependency, another dependency. Okay. So anyway, it was the older code version. This was the modern code structure. Okay. Now the helper function. Another approach is to use a helper function. Okay. You see, each call to delay log. Each call to delay log create its own closure with its own value parameter, right? Delay log with the value parameter, then create this. And again, the for loop, you see there is a function, it's called I, and I into time, and you get the exact result. First parameter is value I, second parameter is time, and this return. Okay. Okay, great. Okay, now another loop example we see. Actually, common scenario. It was the common scenario. Like they create a multiple function in a loop. This is the common scenario. Okay. Because we use let, each function closes over its own I, right? Own I. I value actually. This is the I value. I mean the index value. If we had used var, all three would multiply by 4, right? Not 1, 2, 3. Okay, all right, great. You already seen this function. This is stored the empty array, then looping through it, then return this multipliers and get the exact result. And when you are storing this function as a value, and you get what you actually want to show 0, 1, 10, 10, 20, or 30. Okay, great. So, all right, let's wrap this up with the key point. A closure is created when a function has access to variable from its outer scope, even after the outer function has finished executing, right? Second is closure are a natural result of JavaScript lexical scoping. Third point, closure are incredibly useful for delay privacy, factory functions, and the functional programming patterns. We already seen the basic closure in loop problem happens with the verb because all iterations share the same variable. And the last point is always use the let or const in loop to avoid closure issue. Each iteration gets its own binding. Okay, so remember this. So, and that's closure. I know it can be a bit mind binding at first, complicated, but the more you use them, you more naturally they will feel. Okay, so practice it as much as possible. Don't skip this. Just pause the video again and again and watch it again and again, and then practice. In the next video, we will build on this and talk about the callback function and how closures play a role there actually. Okay. If you found this helpful, make sure to like and subscribe, drop comment if you have any question about the closure. I read every single one. Okay. So thanks for watching. I will see you in the next video.